prefrontal cortex, metacognition, and subjective experience. Welcome back! Okay, now, let's keep in mind that the localists think that conscious experiences are all determined within the early sensory areas, whereas on the other hand, the globalists think that they depend on representations throughout the cortex, including the prefrontal cortex, the PFC. For the globalists, the trouble is that the PFC can probably only represent so much at any given time. Processing at this high level is known to show limited capacity. It may reflect our conscious access, that is, our ability to report and act upon the stimuli in a thoughtful way, but usually we can only consciously focus on just a few things. And yet, we seem to have the impression of experiencing much more than what we can consciously access. Sometimes we say our conscious phenomenology seems to be rich rather than sparse. The philosopher Ned Block argues that our conscious phenomenology overflows access. But the role the PFC plays in conscious perception may not be just to hold the relevant perceptual information via global broadcast or otherwise. For that, we may need a large capacity to support rich phenomenology. But the PFC is also known for another important function, which is metacognition. And this may be how the PFC contributes to conscious perception, in giving us an impression of richness. By metacognition, we mean our ability to monitor how well we can perceive or remember things. For instance, let's say that we set up a simple visual task, discriminating whether a stimulus is a dog or a cat. These experiments are usually set up to be quite difficult, meaning that we may make some errors because the stimulus is not so clear. Afterwards, we can ask the subjects to rate their confidence as to whether or not they think that they were correct in that trial. Typically, confidence predicts accuracy to some degree. When we say that we're sure, we're more likely to be correct than when we say that we're not so sure. How well this confidence predicts our accuracy is sometimes referred to as our metacognitive capacity. It's known that the regions of the PFC, especially the anterior frontal polar region, the APFC, and the dorsolateral prefrontal areas, the DLPFC, are important for metacognition. So by now you're probably somewhat familiar with the DLPFC, and the frontal pole, the APFC, is just anterior to it. In studies measuring structural MRI, it was found that people with higher gray matter density and volume in these areas showed higher metacognitive capacity, especially in perceptual tasks. One such study was done by Leanne McCurdy, who was only an undergrad when she published this important work. But this is not to say that the PFC is only important in tasks in which we measured metacognitive capacity. Sometimes, when we asked people just how well they consciously saw the stimulus, that subjective report itself, regardless of how well it predicted accuracy, could be reflected by activity in the PFC too. For example, in one study using fMRI, the subject's task was to discriminate if the stimulus target was a square or a rhombus, which is just a square tilted by 45 degrees. The stimulus was then quickly followed by a mask. This kind of mask is called a metacontrast mask. Unlike a pattern mask, the metacontrast mask did not overlap with the target spatially. It only surrounded it. Now, there were two task conditions which differed by the SOA. The SOA refers to the stimulus onset asynchrony, which is just the difference between onset of the target and the mask. The subjects were equally able to discriminate the target in both conditions. But due to the timing of the mask, people reported consciously seeing the target stimulus more often in one condition over the other. That is, they reported that they were guessing less frequently in one condition. The feeling of just guessing is quite common when the stimulus is hard to perceive. In other words, the experimenters found two SOAs such that people were equally able to perform the discrimination task, even though they reported that they subjectively saw the stimulus better under one SOA over the other. They found that under the condition in which people saw the stimulus better, there was a higher bold activity in the DLPFC. Remember the issue of confounds from the previous class. The fact that subjects were equally able to discriminate the target is quite important. It gets rid of the confound of task performance capacity. From there, one can argue that the sheer signal strength of the visual representation at a cognitive level is probably quite well matched between the conditions too. This may be why, when comparing the conditions, the researchers did not find bold activity difference in the visual cortex. You might think, if people were just as able to discriminate the target, how different could the subjective experience be? Admittedly, in the experiment we just talked about, the difference was small. The rate of reported guessing was only lower in one condition by about 10%. But we can observe larger differences in subjective awareness between conditions in patients with brain lesions to V1. These patients may show blindsight, a condition under which they report having no conscious experience whatsoever in the affected visual field unless something is moving quickly. And even then, it's not clear if they're consciously seeing the motion or if they just develop a gut feeling that something moved. And yet, when we ask the subjects to press keys to discriminate what the stimulus was, they can often do it well, better than chance, sometimes up to 80 or 90% correct. They do so while maintaining that they were just guessing. To describe this paradoxical phenomenon, Larry Weisskranz coined the term blindsight in the 1970s. In one fMRI study, blindsight patient GY was scanned while he did these visual tasks. His V1 damage was to the left hemisphere, meaning that the right visual field was subjectively blind. The experimenter presented a strong stimulus to his blind field and a weaker stimulus to his intact visual field, so that the task performance, that is, his ability to do the discrimination task accurately, was matched, just as it was in the metacontrast masking fMRI experiment that we mentioned earlier. And yet, GY consciously saw the stimulus in the intact visual field often, but never in the blind field. This big difference in conscious experience was reflected again in the DL-PFC, as well as in other prefrontal and lateral parietal areas. Again, in terms of dealing with the confounds of task performance capacity and signal strength, one can see why blindsight is so important. It's rather unlike binocular rivalry or other experimental paradigms. Here, the subjective percept and one's ability to do simple tasks come apart. This gives us a rather unique opportunity to understand the neural correlates of consciousness, NCC, free from these confounds. So it seems like there is activity in the PFC which reflects not just metacognition, but perhaps our subjective experiences as well. This is not just about being able to represent the stimulus to do the relevant tasks. Instead, the activity in the PFC may closely reflect our subjective experiences.